Okay, this one over here, for some reason, this one over here, it does pop up. All right, so it'd be nice to remember that one, because I'll be honest with you, deriving it might be a little problematic. So what I want to do is I want to go through the derivation of it, and someone says, what's the derivation of that? Is, let me make sure I didn't skip anything. No, I didn't skip anything. So I'm looking at this one, I'll write this down, and this is one we did in class, by the way. So I'd write it down as, let's see, secant x. Again, I don't think deriving is a good idea, and I'll tell you why. If I had to remember this part here, the unit factor that we're going to be using, I would know the antiderivative. But let me just go through it. We gave you this in class, by the way. We gave you a hint. We gave you this hint over here. We said multiply the integrand by a unit factor, and that unit factor is secant x plus tan x over secant x plus tan x, which conditionally is 1, by the way. Now, if you did this, you get something pretty simple. You get this over here. You get secant squared plus secant x tan x dx all over secant x plus tan x. Then you make a u substitution, and this was actually taught in the section after u substitution. Let's write this down. This is going to be secant x plus tan x. And if you take that guy's derivative, well, let's say differential du, what are you going to get? Well, let's see. The derivative of secant is secant x tan x. That's fresh in my mind. And the derivative of tangent is going to be secant squared. And it's going to be dx. Do I see this here? I do. So what am I left off with? Kind of simple integration over here. Making a u substitution. It's going to be 1 over u du. This is going to be the natural log of u plus some constant of integration. Well, what's the u? That's a substitution we just made. And that u, where was that? Oh, right over here. It's secant x plus tangent x plus some constant of integration. Is that what we're seeing over here? It is. We're seeing the natural log of the absolute value of secant x plus tan x plus some constant of integration. All right, depending on your teachers, like for example, I don't expect my students to remember this one. Like if a student on exam said, could you give me the antiderivative of secant? I'd say, sure, let me give it to you. Now, I'm not going to say it was right or wrong that they'd need that, but I would give it to them if they wanted it, right? So the deal about this one over here, depends who your teacher is. I wouldn't expect memorization of this one over here. But this is useful. And what I mean by useful, it does pop up. You're going to see it pop up in these 50 integrals, by the way. Thank you.